Welcome to the video on midpoint. As a reminder, as you're going through this video, if there are things that I say that don't make sense, please don't be afraid to stop, rewind the video, and replay the video so that you can get a better understanding of the material that's being discussed. First of all, what is a midpoint? I like to think about a midpoint as being kind of a center place. Or in other words, the place or the point that splits something into two equal parts. Now, because lines and rays extend indefinitely, in other words, they go on for an ever and ever, it's impossible to find the center place of a ray or a line or even an angle. So the particular something that we're splitting into two equal parts when we talk about a midpoint is actually a line segment. Line segments are the only geometric shape that I know of that have midpoints. All right, so let's go ahead and take a look at some line segments and their midpoints. In example 1, it says point F is the midpoint of line segment EG. If EG, the distance between points E and G, is equal to 5x plus 4, and EF, in other words, the distance between points E and F, is equal to 2x plus 37, they want us to find x and the length of line segment FG. Now, just so that I can get a nice visual idea of what's going on in this problem, I'm going to start by drawing a picture because they haven't given us one to work with here. So we're talking about this line segment whose endpoints are E and G, and we know that point F is the midpoint, or the center place, or the point on that line segment that splits that segment into two equal parts. So I'm going to show in my diagram that those two parts are equal by marking both segment EF and segment FG with a hash mark. The distance from between points E and G is 5x plus 4. So E to G would represent the length of the whole line segment. And likewise, the distance between points E and F, well, E and F would be that little green line segment, is equal to 2x plus 37. And now that we've labeled all the information in the diagram, what we really have to look at and discuss and think about is the relationship between the length of the green line segment and the length of the whole thing. So I'm hoping that at home, as you're watching this, you're recognizing that the length of the green line segment is equal to half that of the blue one. Or in other words, the blue one, the whole thing, is equal to double or twice or 2 times as much as the green one. So I'm going to go ahead and write an equation then that talks about the blue one being double the green one. So the length of the blue one is 5x plus 4, and we want that to be double or twice the length of the green one. So 2 times the quantity 2x plus 37. So now in order to solve for x, I'm going to have to go ahead and use the distributive property on the right-hand side of my equation. When I do that, I end up with 4x plus 74. And now I'm at a place where I have a lot of different options as far as how I want to go about solving this equation. I'm going to go ahead and subtract 4x's from both sides of the equation. But again, there are lots of different right ways that'll get you to the right answer in the long run. So if I mentally subtract 4x from both sides, on the left side I'm left with x plus 4. And on the right side, after mentally subtracting 4x, I'm left with 74. And then I'm going to go ahead and do the same thing and mentally subtract 4 from both sides, leaving me with x on the left side and 70 on the right side. So I've now completed the first task that was required of me in that problem, and that was to find x. The second task that I set out to do was to find the length of line segment FG. So if I go ahead and look at the picture, FG is that purple segment right there, and its length is equal to the length of the green one. So if the green one measures 2x plus 37, the distance between points F and G must also be 2x plus 37. So I'm simply going to substitute in that value of x of 70 that I got, and then go ahead and simplify that expression. And when I do that, I find out that the distance between points F and G, or in other words, the length of line segment FG, is equal to 177. Number 2 is quite similar to number 1, so in the interest of time, I'm going to go ahead and skip over number 2 because I do want to take some time and have a discussion about what happens when we're dealing with midpoint in the coordinate plane. To find a midpoint in the coordinate plane, we have a few different approaches that will work for us. We can graph, and that would work quite nicely to be able to determine a midpoint. We also think the other thing that we can use is a formula. And I think I'm going to tackle part A by doing both a graph and the formula. So it says find the coordinates of the midpoint for a segment with the given endpoints. Just like the first example, because we haven't been given a picture, I'm going to go ahead and plot these on the coordinate axes so that I get a nice visual understanding of exactly what it is that I'm working with here in this question. And if I were to look at this picture or look at this line segment on the coordinate plane, I'm looking at this and I'm saying that red dot is probably that center place or that center point or that midpoint that I'm talking about. So I'm thinking probably it's going to be the point whose coordinates are 1, 4, but probably isn't quite accurate enough for us as mathematicians. I have to have some definitive way of saying, yes, definitely this guy's the midpoint. This is definitely the center place. And in order to do that, I'm going to go ahead and build a right triangle. And as I notice, the horizontal change here and moving from B over to A is 6 units. The vertical change is down 4 units. So I know that midpoint or that mid-center place on my graph is going to have a horizontal change of 3 and a vertical change of going down 2 or negative 2. So as long as I go ahead and label my graph with what I've labeled in this picture on the purple, I can get full credit for finding the midpoint graphically. If I choose not to do what's in purple on the graph, I can get credit for finding the answer, but I cannot get full credit for solving the problem. So the moral of the story is if you're going to solve it graphically, make sure you show me what's in purple on your graph. Now suppose you say to yourself, Ms. McCann, that is a lot of work to have to go ahead and draw that graph and write everything in there. Is an easier way to find it without having to draw the graph? And that's where the formula comes in. I'm going to show you a couple different ways to write the formula for finding the midpoint. One way that you'll see it probably if you go online says that the coordinates of the midpoint, x and y, are equal to what you get when you take the two x values from the endpoints and add them together and divide by 2, and then take the two y values from the endpoints and add them together and divide by 2. Now, I know as a mathematician, I know that adding two numbers together and dividing by 2 is the same thing as finding an average. So I think about the midpoint formula as finding an average of the two x values of the endpoints, finding an average of the two y values of the two endpoints, and that then becomes the coordinates of my midpoint. So let's go ahead and find the coordinates of this midpoint now algebraically. I'm going to use the average formula, but you're more than welcome to use whatever formula makes good sense to you. And now I'm going to go ahead and substitute into my formula. My two x values that are given to me for the endpoints are 4 and negative 2. And it doesn't matter which order you plug those in. And my two y values that are given to us for the coordinates of the endpoint are 2 and 6. And so now I'm going to simply go ahead and simplify this expression. 4 plus negative 2 is 2. Divide by 2, you get 1. 2 plus 6 is 8. Divide that by 2, you get 4. So regardless of whether we found it graphically or algebraically, we both ended up at that same point for the midpoint, or coordinates 1, 4. Now that would be our approach if we're trying to find the coordinates of the midpoint. This last example down at the bottom of the page is asking us to do something a little bit different. In this particular problem, they want us to find the coordinates of the endpoint. In order to use the midpoint formula, we really have to know the midpoint formula. We have to know the coordinates of the endpoint. And in this particular case, we're being asked to find those coordinates. So the midpoint formula won't be a particularly effective method of solution for us in this circumstance. I'm going to think about the midpoint again as being the center point or the balance or the middle between those two endpoints. So if I have an endpoint, a midpoint, my other endpoint is going to have to be here at the other end. And again, that midpoint is going to have to exist somewhere as a balance. In this question, we know the coordinates of one endpoint are 6, 2. We know the coordinates of the midpoint are 2, 0. And again, if I think about that whole midpoint as being the center or the balance, that's what's going to help me solve this question here. If I take a look at the difference between the two x values, or the difference in moving from the x value of 6 to the x value of 2, that's a loss of 4. In order to keep that balance or keep that midpoint, I'm going to have that same change in moving to my other endpoint. So 2 subtract 4 leads me to a new endpoint x coordinate of 2. And likewise with the y's, I'm taking 2 away from the y's. In order to maintain that same balance and keep that midpoint in the center, I'm going to have to subtract 2 again, leaving me with my endpoint with coordinates -2, -2. As I did with the first example, if I wanted to put this on the graph and solve it graphically, I'm more than able to do that. I would just go ahead and plot my first endpoint. My first endpoint here has coordinates 6, 2, right there. My midpoint has coordinates 2, 0, right there. And so again, if I'm thinking about maintaining this balance and moving from an endpoint to the middle, I'm moving to the left 4 and down 2. So in moving from that midpoint to the other endpoint, I've got to go to the left 4 and down 2. And I end up at that other endpoint with coordinates -2, -2. But again, if I'm going to solve graphically, I've got to make sure that I show all that nice work on my graph so that I can justify or prove that what I've actually found is indeed that other endpoint. All right, like always, I'm going to have you flip up to the top of the next page and in your own words summarize the key ideas and the important understandings that you need to make sure you can recall from the video. And then make sure that you can answer the questions 2 and 3 on the next page. In number 2, they're asking you to find the coordinates of the midpoint. In number 3, they're asking you to find the coordinates of the endpoint. If you have trouble with either of those, I would recommend that you flip back or rewind the video to the discussion of those coordinate problems at the bottom of page 11.